Hello, y'all. I'm going to do one equation for you today. I just want to show you another weird one. Last class we did a weird one where when we worked it through, we ended up getting something equal to another number, right? Like you ended up with 12 equals 0, or maybe negative 3 equals 4 or something. You know, the x's canceled out and you got something that was definitely not equal to each other. And so we called this a no solution. Okay, or a null set, which means that there's nothing in the set of answers. Okay, what we'll do here is we'll go ahead and I want to show you another situation where we get kind of a weird answer. All right, so let's go ahead and start off. Many of you will recognize that I need to distribute the negative 4. So I'll have negative 4x. Negative 4 times negative 3 is a positive 12. And then I have the negative 3x, and here I've got a negative in front of this parentheses. Now remember, anytime you have a negative in front of the parentheses, you can treat that as a negative 1. So this negative 1 can get distributed to everything in there, which will make it a minus x and a plus 12, because negative 1 times negative 12 is positive 12. Now from this point you can do whatever you want. I like to put the like terms together on this side before I start moving things around. And so I'm going to have negative 4x plus 12 equals, and I put those together, I get negative 4x plus 12. And you can probably already see that this looks kind of fishy. But, you know, if I finish off the problem, I add 4x to both sides because I want to get all the x's over to one side or the other. And you'll notice that here the 4x's cancel out, giving me 12. And here the 4x's cancel me out, giving me 12, which means I end up with 12 equals 12. Now, thinking like a mathematician, how is this the same as what we had before? Well, in this other situation last class, the x's canceled out, right? And we ended up with just numbers. That's how it's the same. How is this different, though? Well, it's different because in this situation, you get two numbers that are equal to each other. Now, in reality, when this happens, when the x's cancel out on both sides and x disappears, this means that x doesn't matter. Okay, x doesn't affect the outcome of our equation. Putting numbers in for x isn't going to change the outcome of what we get. Now, in this situation over here, it didn't matter what x was. We ended up with two numbers that weren't the same and won't ever be the same. And so, therefore, there was no solution. In this situation, the x disappeared, which means it doesn't matter, and yet the equation still works. And because the equation works regardless of what x is, we can now say that x equals all real numbers. Okay, or as we've written before in class, x is of the set of all real numbers. Either one of those is fine, but x can be anything. Okay, you don't believe me? You can plug any number in for x and it will work. I would show you one, but then you'd say, yeah, but it just works for that one. Okay, you try as many numbers as you want, and as long as you follow PEMDAS correctly, it will give you the same number. It won't necessarily give you 12 every time, but it will give you the same number on this side as you get on that side. Every single time without fail. All right, so there I just wanted to show you that quick one, and now you should be able to start on your homework. Ciao.